In this video, I will demonstrate the functions of the updated version of the Community Water Data Analysis tool. This is the screen that you will first see when you launch the app. It gives a little bit of introductory information in terms of what the app is, who can use it, why you should consider using it. The how-to video, which you're watching right now, is provided on the page, as well as some information on the accepted data formats and reference information for the built-in datasets that have now been added to the app. What you should also notice up at the top is the three tabs: Reference Dataset, Test Dataset, and Paired Site Comparison. These are all drop-down menus. If you click on one, you will see a number of other pages which you can select: Data Upload and Properties, Spatial Visualization, Graphic Visualization, Statistics, and Temporal Coverage Summary. So to get started with the app, the first thing that you have to do is either provide some data or indicate to the app that you want to use the built-in data, which is what we'll do now. So click on Data, Upload, and Properties to get started. Your options here are to use your own data. You would click on Mine, or click on the built-in bullet point to automatically load some pre-existing data from the app, and that data came from Environment and Climate Change Canada with the citation and disclaimer information on the About CWDAT page. So as soon as you've loaded a dataset, either your own or the built-in dataset, there will be a number of drop-down menus here, and this is to select which column refers to each bit of information. You require a column with a unique site identifier, whether that's a name or a number, a column containing date and time information or just date information, a column for longitude values, a column for latitude values. CWDAT accepts both long and wide format data. If it's long format, you also have to have a column for variable names and for your data values. If it's wide, which I'll demonstrate here, you're going to have to select the columns which contain those observed water quality parameter values. But in this case, the default is long because this is the built-in dataset. I'll just do a quick demonstration of what it would look like if you were using your own dataset. If you click on Mine and click on Browse, this will open up the File Explorer, and then you can just select whichever data frame you want. So let's use this one. And again, if you're using a wide format, you need to tell the app where to find the data. So once you're done with your column selections, you'll notice that I hit Submit Column Selections, and then you get this confirmation message. In this case, it says you have provided your own dataset with a wide data structure. So just click OK or click outside of the box to move on. Also notice that a preview table appears to the right once you've added a data frame, and this is basically just to help you see what's in the data and what the various columns look like. So if you're not familiar with the data set that you're working with, then you can use this to help you figure out which columns should be included here on the left. Now that the data has been provided, the next tab is Spatial Visualization. Again, don't move on to those next tabs unless you've already added data. Click again on the Reference Data drop-down, and now click on Spatial Visualization. Depending on the size of your reference data set, this page may or may not take some time to load. So the Spatial Visualization page is really meant to help give you a preliminary overview of your data and where it was collected. The map here at the top left will display the location of each unique water quality monitoring station listed in your data based on those longitude and latitude columns that you specified earlier. You can zoom in a little bit too if you want to. If you scroll down, you'll see a table similar to the one on the previous page. This table also offers filters which impact what is shown on the map. Using this, and especially if your data is in the wide format, you can actually see the numerical range of some of your water quality parameters. For instance, here's the range of pH from 5.78 to 8.79. To see a basic scatter plot of your data at any station, simply click on a station of interest, and use a drop-down menu to select the parameter you would like to view. Now the selections available here, if you're using a wide format dataset, are the same ones that you specified on the Data Upload and Properties page. So let's take a look at turbidity, for instance. And the map is interactive, so you can zoom in on it, you can hover over it, you can take photos, or you can pan around and zoom out. And auto scale, all of those functions are available by default. Also, make sure to pay attention to what units your data is using. Future versions of this app will incorporate unit handling, but for now it's something that you just have to keep in mind. So the next tab, Graphic Visualization, can be accessed in the same way as before by clicking on the reference dataset, or test dataset dropdown if that's where you're working, and clicking on Graphic Visualization. As a side note, if and when you want to return to a page you've already worked on during your session, the last inputs will still be there until you close out. So the menus on this graphic visualization page can be a little bit busy at first, but we'll go through each part individually. The first choice you can make is to select between univariate or single variable visualization or bivariate visualization, which uses two variables. For example, if you wanted to only look at the distribution of, say, alkalinity, you could use univariate. If you wanted to visualize your alkalinity data across time, you would use bivariate, with your date column as the x variable. Let's start with the univariate example. The next step is to choose which of your sites you want to include in the graphic. Let's pick 3 or 4 for this example, although by default, all sites are selected. So by scrolling up and scrolling down, you can see the list of site names in alphabetical order. To deselect all the sites, hit deselect all, and to reselect all of them, you can hit select all. And you'll notice that as soon as you make any changes to these drop-down menus over on the left, the graph to the right automatically updates. So let's deselect and then reselect a couple of different random sites and just see how that looks. Just as with the site selections, you can also select which months you want to include or which months you want to exclude using the same interface, the deselect all, the select all, and the ordered list. The next choice is to select the variable to display or variables if you're doing bivariate visualization. Let's stick with pH. And you can also choose your plot type. There's histogram, density, or if you want to categorize discretely, you can have a box plot or a bar plot. There's also the option to enter the name of the graph. Apparently earlier I entered in whoop and that updates automatically. And of course, if there are units, you can add the name of the units, although in this case pH is unitless. And again, that will update automatically. The button down here allows you to download a PNG version of the plot that you see over here to the right. So if you're interested in putting this into a report or you just want to save it for future reference, that's how you can save what's on the screen. The next tab from the drop down at the top is Statistics. Again, the page will load momentarily depending on the size of your data set. Let's take a look at what's going on here. There are 2 tabs, Summary Statistics and Normality Testing. There's also a box to select a site and to select a parameter. Thus, the stats given here, which include a box plot for all of the observations, monthly observations, and yearly observations, are for that particular site and that particular parameter. Now, if you'd like, you can generate a PDF report for the parameter that you've selected, but it would be across all sites. So what that's going to give you is that's going to give you automatically a number of reports in PDF form, and those are all going to be put into a zipped file that you can then download and access locally. So as you can see down there, it's preparing the reports, and it will tell you the progress as it goes along based on the total number of sites that you have in your data set. So in this case, the total number of sites is 45, so the program will just iterate through each of those sites and prepare the reports accordingly. And again, these are outputted as PDFs. Moving on to the Normality Testing tab. This page may not be useful for everyone. It's basically a preliminary check on the normality of your data. So this is good to do prior to using any more advanced statistical tests that may have assumptions of normality or require that your data be not normally distributed. The same selections you make on the Summary Statistics page will be maintained here, but of course you can switch your site and or your parameter of focus, just like before. It automatically displays a histogram, and below that there are results of the Shapiro-Wilk normality test for the raw data and for log transform data. If you're not familiar with statistics, don't worry too much about this. The next couple of comments are just additional details for the sake of transparency. The Shapiro-Wilk tests were done in R and the confidence interval is 95%. As such, our threshold value for the p is 0.05. If the listed p-value is less than 0.05, that means that we can assume that the data for the selected variable at the selected site is significantly different from the normal distribution. We apply the same criterion to the log transform data. If the p-value is less than 0.05, we assume that it's significantly different from the normal distribution. Keep in mind that the number of data values or number of observations has an impact on how accurate this test is. So don't assume that this particular test is completely appropriate for your specific data set. So that finishes up with the two statistics tabs. Let's move on to the temporal coverage summary, navigating the same way that we've seen before, using the drop-downs. This page also generates graphs, but focuses on the data collection dates. So if you're looking to see what times are sampled more than others, or want to get an idea of what your period of record is, or if you just want to brag about how much data you've collected to date, this is probably a good tab for you. You have two options to start. You can summarize by month, which will give you months along the x-axis in your graph, and color code by year, or alternatively, you can group by year and color code by month. So it's just a question of whatever feels more intuitive for you. You also have three options in terms of what data is included in the summary. You can do a single site summary, in which case you'll have to select a monitoring site, a complete dataset summary, which uses all of the sites and all of the data, or you can summarize by groups. So say you've got different regions that you want to summarize, or different jurisdictions, or even maybe by different data collectors. You can go ahead and view that as well, just by clicking C, and then you'll have to select the group column, submit the group column, and then select which group from that group column you would like to look at. Now, as with some of the other features in this app, you can always save the plot that you've generated as a PNG just by clicking on click to download your plot, and it will bring up your file explorer so that you can choose where to save that. Additionally, and just like with the statistics, you can now generate a PDF report of the temporal coverage summary just by clicking on click to generate a PDF report. And again, that will iterate through all of the different sites, and it will output one PDF file for each site. So that's it for the functions that draw from a single dataset. Before I move on to the paired site comparisons tab, I'm going to add a test dataset file. Or actually what I'm going to do is I'm going to go back and I'm going to use the built-in reference file that the app provides. I'm going to resubmit those column selections. It'll take a little bit. There we go. And now I'm going to add a second dataset. In this case, I'm going to use the built-in community-based dataset, or test dataset if you prefer. And by default, these are the columns that are selected. Everything else looks good, so I can hit submit here, and I'll get that same notification as with the reference dataset. I should note that this particular community-based monitoring dataset originated from the Northwest Territories-wide community-based monitoring program, and I accessed it through Mackenzie Datastream's website. And the information for that is on the front page, the About CWDAT page. Again, we'll go from the top drop-down and click on Site Pairings. The first thing you want to notice about this page is the text entry box at the left. That's right here. This is asking you to tell the app just how close together do two sites, so one from the reference set and one from the test set, have to be to count as a pair. The text is there as a little reminder that for this to work, you do have to specify that maximum distance. The unit is kilometers, and keep in mind that this is Euclidean or straight line distance, proverbially as the crow flies. I'll try 2 kilometers to start. Once I do that, all of a sudden all these other boxes pop up in the map, and we'll go through those one by one. The first thing you want to do is to look at the table at the top, which lists the generated pairs based on the maximum distance in kilometers that you specified in the text box. In this case, there are 5 different pairs available. The station unique IDs are given, the distance between them in kilometers is given, and each pair is assigned a number. This number corresponds to the box in the top left, which is asking you which pair should be addressed. Whichever pair you select, so let's go down to number 4 for instance, this will show up in the map to the left as well, so that you can make sure visually that those sites are maybe where you would like them to be. For instance here, this might be referring to the larger channel, and this could be referring to the tributary, so you just want to take care and make sure you find one that makes sense to you. These two look like they're along the same channel, so we'll stick with them for now. Once you've selected your site pairing that you'd like to work with, the next step is to select a parameter from the reference dataset and its corresponding parameter from the test dataset. Now this is where you have to be very careful about not only your naming conventions, but also your units. Because the only way this comparison of the two sets of site data works is if those units are the same and if the parameters themselves are the same as well. So let's go to pH from the reference dataset and select pH from the test dataset as well. Now from the test dataset you are able to compare a certain month, for instance all of the data from June in the test dataset against all of the June data in the reference dataset, and that, according to the slider, goes from 2001 to 2019. Now the more data you have in your reference baseline, the better it's going to be when you go to compare your community-based monitoring data or your test dataset. So once you've made your selections and ensured that your slider is where you want it to be, the last step is to click to compare. Once you've done that, some text will pop up as well as a graph. We'll take a look at the graph first. You can see that there's two different colors. One color is for the reference dataset, and the other color is for the test dataset. And here we can see that there are only 2 data points from the test dataset, but that's alright, you can still run the calculation. So here the text says the difference between the test and reference means is not significantly different from 0. In fact, it's very likely that the datasets have the same mean. However, the test data could be near the edge of the normal range of the reference data, but it's likely falling within that normal range. Look at the graph below to see the data being compared, and again, just a little reminder that for this test to work, the variables and the units both have to match. So you can try with another month and do the same thing. Things will look a little bit different. So that finishes up the description for the paired site comparison page, and that wraps up the how-to video for the Community Water Data Analysis tool. One more time, I'd just like to reiterate that this is a pre-alpha version of the app and is still being validated, fixed, and updated, so please don't base your decisions entirely on these outputs, and please make sure to follow any and all other rigorous scientific and procedural steps for data analysis and decision making that you may have already established for yourself, for your organization, or for any other purpose. Once again, this is a pre-alpha version. So this concludes the how-to video. Thank you for taking the time to watch and to help develop this free resource.